Very good morning to all of you. Today we will discuss numericals on temperature stresses. So on in last video we have discussed some of the theory portions. On that theory portions is little portion left, that is nature of the stresses. Nature of stresses means when heat added and ends are fixed, at that time the body will try to expand, but expansion is prevented. So expansion is prevented means the nature of stress is compressive. When we are adding heat and ends are fixed, at that time the nature of stresses is compressive. Similarly, during fall in temperature or cooling condition, when we are cooling a job or a member and its ends are fixed, at that time the nature of stress is contraction. That means contraction of the body will be there, but expansion is prevented. So the nature of stresses is tensile. So to remember this, only 2 points. During addition of heat, the nature of stresses is compressive, and during cooling or fall in temperature, the nature of stresses is tensile. So this is regarding nature. So when we will solve numericals, it is depending upon the questions. What is in the question, what are the data given? If addition of heat means the stresses develop is compressive. So we will start the numericals. The data given: length of the member, original length of the member, L is the length of the member, that is given 2 meter. Original length of the member 2 meter. Initial temperature is 10 degrees centigrade. Initial temperature, say T1, is 10 degrees centigrade, and the temperature raises to 80 degrees centigrade. That is final temperature T2 is equal to 80 degrees centigrade. So initial temperature T1 is 10 degrees centigrade, final temperature 80 degree. So rise in temperature, the value of T is its difference, 80 minus 10, that is 70 degrees centigrade. 70 degrees centigrade. 70 degrees centigrade. And another other data, Young's modulus is given and coefficient of linear expansion. Young's modulus is given, Young's modulus, capital E. That value is 2 into 10 to the power 6 kg per cm square. And alpha, coefficient of linear expansion, is 12 into 10 to the power minus 6 per degree centigrade. This is the data given. So from this, the question is find the stresses in the material and find the expansion of the rod. So first bit is expansion of the rod. Expansion of the rod. We have to find out expansion. Expansion of the rod. Expansion of the rod means, that is, we have to find out delta L. And second is temperature stress. So these are the two finding we have to find out. First one, expansion of the rod, and second one is temperature stress. So for delta L, simple, there is a formula, that is from coefficient of linear expansion, alpha is equal to delta L by L per degree rise in temperature. From this, alpha value is equal to delta L by LT, or delta L is equal to alpha into L into T. So this is the formula for delta L. So we have to find out expansion of the rod. That means delta L is equal to, put the value, that is alpha value 12 into 10 to the power minus 6. 12 into 10 to the power minus 6 into L, length of the member. Length of the member is given 2 meter. 2 meter into T, that is 70 degree. So from this, by calculating, delta L value will be, delta L value is 0.168 centimeter. 0.168 centimeter. This is delta L value. By calculating, by using calculator. In your exam, you will use calculator. So by using calculator, this is the value, delta L. Next, stress, temperature stress. That temperature stress formula is, from basics, we know this, F is equal to capital E into small e, that is equal to Young's modulus into E value, E, that is delta L, E value, delta L by L, that is equal to E into, put the value alpha L T by L. So simplify it. F value will be simplify LL cancel out. So stress value is exactly E into alpha into T. This is the value, E into alpha into T. So by putting this value, this is Young's modulus. Put the value of stress is equal to 2 into 10 to the power 6 into alpha, that is 12 into 10 to the power minus 6 into T, that is 10. So the value of F is exactly 1680 kg per cm square. 1680 kg per cm square. So this is the stress. This is the answer. So first bit answer is delta L expansion is this much, 0.168 centimeter, and stress, temperature stress value is 1680 kg per cm square. Only the last part is nature. So here we are adding heat. So addition of heat means the stress developed is compressive in nature. So finally you can write down the nature of stress is compressive. Nature of stress is compressive. So this is all about the numerical. So this type of question is coming in your exam regularly, this type of questions, and you will get definitely one question from temperature of stress. Okay, thank you for your watching.